We are starting our PHDwin Week Ethics session shortly. We'd like to share some background on David Clark. David Clark has 12 years of experience across multiple unconventional and conventional reservoirs, with a focus on reservoir engineering, reserves estimation, and data analytics.
He is currently a reservoir engineer at Marathon Oil. David has made this year's presentation a must for any petroleum engineer. As things in the industry change, David's conversation focuses on ensuring integrity as a part of the process. Please welcome David Clark, presenting Ethics in Forecasting.
Hello, fellow industry professionals. My name is David Clark, and I will be your guide for the next hour on Ethics in Forecasting. As a bonus, for any professional engineers or SPEE members watching today, this will count towards your annual ethics requirement. Also, before we get started, I do want to send out a special thanks to the fine folks at PHDwin for inviting me to speak. I'm honored to be here and to be able to talk to this group. I do need to give the obligatory disclaimer before going into the material. The views and opinions in the following presentation were created independently by the author, me. None of the content herein should be interpreted as official policies or positions of either TRC Consultants or my employer, Marathon Oil. If you do have any questions, concerns, or would just like to talk about this further, feel free to reach out directly to me. I generally don't like to toot my own horn too much, but I suppose since I'm going to be speaking at you for a while, some introductions are in order. A little bit about myself. So my current role, I'm the manager of corporate reserves at Marathon Oil. Although if you're following the news at all, you'll know that Marathon Oil will cease to exist in the near future as we are being purchased by ConocoPhillips. However, I remain enthusiastic and excited about whatever the future holds for me. I've held various roles over the last 12 years at BP Alaska, Chesapeake Energy, and then my current employer, Marathon Oil. All my positions have been reservoir engineering related, and then more recently I've had a focus on just reserves estimation and data analytics. I do have a Bachelor of Science degree in petroleum engineering, and I actually just finished my Master of Science degree in petroleum engineering at Texas A&M. And a side note on that, the Texas A&M Petroleum Engineering Department has really stepped up their game in the past few years. So you can get your graduate degree almost entirely remotely. So for any of you who don't have an advanced degree but are interested in getting one, definitely look into the program. It's something that you can do while you're working full-time. Let's see, I've also listed some other credentials and memberships for completeness, but I won't go through those. When Dr. Wigley approached me and asked, would you do a 1-hour ethics presentation at PHDwin Week? First, of course, I was flattered. Well, of course, it's such a great honor. But then this looming question started to percolate in my mind. Am I qualified to do a 1-hour talk on engineering ethics? So let me pose the question to y'all. Who qualifies as an expert in engineering ethics? Engineers? Geologists? I think so. How about technicians or executives? Maybe a little more ambiguous there. Probably most importantly, do you qualify as an expert in engineering ethics? And I'm certain I'm going to get some differing opinions from the group, but my stance is this. If you touch an engineering process, regardless of how big or small the contribution is, then you are an expert in engineering ethics. When we drill or complete a well, when we perform well work or create a forecast, all of that, it's expected to be done ethically. And if it's ever found out that the work was deficient ethically, then there is no lenience from the government, from investors or the public or your manager. The hammer will come down. So, I pose to you that we are all experts in engineering ethics. So you've probably guessed from the title of this presentation that the focus of this talk is ethics in forecasting. However, to begin our venture into the consequences of ethical shortfalls, I'd like to start with a couple of so-called obvious examples where some sort of ethical dilemma ended up in a physical outcome that damaged property or even hurt people. So I'd like to briefly cover two examples, the first of which is Lake Peigneur in Louisiana, and then the Texas City refinery in the Houston area. So let's start with Lake Peigneur. And if you aren't familiar with what happened, in 1980, a Texaco drilling rig in a Louisiana lake encountered a salt mine. This effectively drained the lake into the mine in a giant vortex of water. It sunk barges. Subsidence destroyed property in the surrounding area. And as the mud and water were compressed into the mine, explosions blew out of the air shaft. Amazingly, no one was killed in the incident, likely due to the rigorous evacuation procedure that the mining company had. So what was the cause? An engineering miscalculation. One of the three measurements when triangulating the bit location was incorrect. So, at 1,300 feet, they unexpectedly encountered the mine. The following pictures were taken directly from the Mine Safety and Health Administration report, showing the aftermath of the incident at Lake Peigneur. On the left, a massive geyser of mud and water can be seen, having been blown out of the mine's air shaft after compression. Further in the distance, the crater where the rig once stood now shows the remnants of the 100-foot barges that were previously sucked into the massive vortex water. The picture on the right shows one of the many properties that were damaged. The mine inundation caused massive subsidence and landslides, destroying structures in the surrounding area. Next up is the Texas City refinery. In 2005, at a BP refinery, a blowdown stack, which is used in one of the processes, unexpectedly filled with hydrocarbon fluid. As a result, a large vapor cloud emanated around the area, eventually finding its way to a running truck. A violent explosion occurred, killing 15 and injuring 180 more. So what caused this disaster? Numerous failures. First, there were fundamental design deficiencies in the system. There wasn't enough instrumentation for sensing liquid levels. Also, there was a reliance on manual operator intervention to shut down the process. Regulatory bodies also put out reports that suggested that there was a widespread lack of focus on safety at the refinery. The damage from the explosion is evident in the following pictures taken from the U.S. Chemical Safety Board investigation report. On the left, trailers that were surrounding the area have been completely demolished. The blowdown stack, which emitted the flammable vapors, is highlighted in the background. In the picture on the right, the remnants of the truck responsible for igniting the giant cloud of hydrocarbons is seen. The previous examples make a strong case for the need in ethics in engineering. Drained lakes and violent explosions, these are the poster children for regulations and ethical standards. However, what happens when the ethical failure doesn't lead to loss of life and property? And that's exactly what I'd like to explore in the next example, an ethical failure in forecasting. So next, I'd like to go over what happened with Shell when they restated their reserves in 2004. Early in 2004, Shell announced it had miscategorized reserves going all the way back to 1998. This wasn't just a simple correction either. It was to the tune of billions of barrels. It resulted in fraud investigations from the SEC and the British counterpart, the FSA. Class action lawsuits were filed by investors, and Shell ended up paying the better part of $1 billion to settle all the matters. So what happened? We'll take a deeper dive in the following slides, but it boiled down to a few key factors. First, the internal guidance for estimating reserves was misaligned with SEC requirements. Second, management prioritized performance indicators at the cost of being compliant. And third, once this problem was too large to ignore, they delayed removing the miscategorized reserves. So how bad was it? These tables are pulled directly from the SEC press release after their investigation. The top table shows the volume and associated smog valuation reductions versus what was originally disclosed. The max reduction occurred in reserves reported at the end of 2000, a whopping 25% overstatement of Shell's proved reserves. The bottom table is the reserves replacement ratios Shell originally touted, along with what those results were after accounting for the restatement. 1998 through 2000 were hit the hardest, as this was when a new methodology was applied, drastically increasing the reserves. So the question is, how did Shell miss the mark by such a huge amount? It all started when the company realized its reserves metrics were lagging behind its peers, and it was assumed they were simply being overly conservative. So they formed a value creation team, or VCT, to look into the problem. The VCT did look into the problem and concluded Shell was indeed conservative when it came to PDP estimates, but they were being aggressive in the timing of PUD bookings. So they made a recommendation: switch to fully deterministic estimates so that you're aligned with what others were doing in the industry. And here's where the problem began. Management adopted the VCT's recommendation in part for mature fields, but it directed teams to use so-called expectation volumes for estimates of proved reserves. This had exactly the result management was looking for. 1.2 billion barrels were added in just the first few years. They likely expected people to notice the change and included a very short and ambiguous statement in their annual report. Estimation methods have been refined. But there was a reason for the substantial increase. The SEC requirements were no longer considered when estimating proved reserves in mature fields. They were using expectation volumes. All the constraints that apply reasonable certainty were ignored. Of particular note, the company commitment to future development required approval from governments and other regulations, and recovery calculations that stay within the tested limits of the reservoir. None of these applied to the expectation volumes for mature fields. As you can probably expect, the good times did not last forever. Eventually, technical experts in the company began to voice concerns. Reserves estimates in Australia, Nigeria, and Oman were particularly outside of SEC guidance. Management did communicate this to the board of directors, but never recommended debooking any reserves. The consensus was that either the volumes could be gradually debooked over time, or simply remain on the books until the SEC conditions were eventually met. However, it became clear that neither option was viable. Shell finally came to the conclusion that it had to write off the reserves, and so in 2004, it restated its previous disclosures, creating a highly visible and embarrassing situation for the company. We've now seen different types of examples of ethical failures. The incidents at Lake Peigneur and the Texas City refinery resulted in serious safety implications. Property was destroyed, people were killed and injured. Now contrast that to the Shell's reserve restatement. It may not have resulted in damaged property or the loss of life, but it was still an ethical failure of catastrophic proportions. So a couple of questions I'll pose. Should ethics apply differently in these situations? One resulting in physical safety and the other just misleading investors. How do you compare the damage between these situations? Is it monetary, reputational harm? My thoughts are ethics standards do not change regardless of the potential outcome. All of the previous events resulted from some sort of ethical misalignment, whether it was diligence in calculations, prioritizing efficiency over safety, or ignoring requirements to boost performance metrics. And in each of these cases, individuals were harmed. Shell may not have drained the lake into a mine, but they misled investors and severely damaged the reputation of the entire industry. With the remainder of the presentation, I'd like to bring us back down to earth, so to speak. Now, I've been fortunate to not have any personal experience with a disaster or a reserve scandal, but I have seen some behaviors that deserve some ethical consideration. So, 4 behaviors that I most commonly see that deserve some discussion include sandbagging, that's adding sand to your forecast to lower expectations, the gradual write-down where we know we need to write down the reserves, but we slow walk it to avoid attention, misinformed modeling where maybe we're applying a model in a incorrect way, and then creative interpretations where we might be stretching the regulations in a way that favors us. During the live Q&A session that we'll have later in the day, I'd also love to hear some examples that you have that maybe aren't on this list. So let's dive in. Probably the most common behavior I see is sandbagging, and I expect that this is the same for a lot of you as well. I'm fortunate though that in my current role this is no longer a problem, since as reserves manager, asset teams are constantly trying to justify as much proved reserves as possible. They get no benefit from lowering my expectations. But I have seen this with best estimate projections that feed into development planning or other business decisions. As the name suggests, sand is added to the forecast. In other words, the forecast is below what the engineer actually thinks the best estimate is. The benefit for the engineer is that if performance is lower than the true best estimate, you don't have to bring the bad news to your boss, as you already lowballed the forecast. On the flip side, when performance is at or above the true best estimate, it's a pleasant surprise, met with smiles and back pats. Congratulations, it's another winner, exceeded expectations. So why does this deserve an ethical analysis? Because poor forecasts can lead to poor decisions. Optimizing development plans and making informed acquisitions, those rely on a correct assessment. On the extreme end, if you're planning a large project, other processes rely on the best estimate of the forecast. For example, sizing a facility. So how do we solve this issue? It may not be an easy task, but we need to try to get the decision makers to think less deterministically and more probabilistically. We need to communicate the uncertainty surrounding the best estimate. An even better solution, provide the range of potential outcomes. It could be as simple as here's the P10, P50, and P90 projections, or as complex as a Monte Carlo simulation. But if we add the uncertainty to the best estimate, then we no longer have to sandbag to avoid those negative surprises. The gradual write-down. Now this is one I do see in my current role. Let's say you have a forecast for a brand new well, but 1 year later, production is tanked. The actuals are coming in and it's far below your initial forecast. Now you are facing a potentially substantial write-down. And it's tempting to take a small, less noticeable change each cycle until eventually, after enough small changes, the forecast aligns with actual performance. The smaller the change, the less attention the change gets. The less attention the change gets, the less chance you have of getting tough questions. The issue this creates is more obvious than the sandbagging example. The problem is that you are continuing to overstate the reserves until you finally make that last step change. Also consider that if this is approved forecast, it very well may be used as an analog for proved undeveloped locations. So not only is this single well overstated, the error can be compounded when you're rolling this up to the total proved level. Unfortunately, there is not an easy solution to this one. You just need to take the write-down and take it at the time you see the need for it. However, you can use it as a learning opportunity. Was it operational? Maybe apply risk factors to future forecasts. Was a model to blame? Well, now we have a new data point to recalibrate and improve other forecasts. Or maybe it was just reservoir deliverability was bad in that area. Okay, now let's delineate and refine the static model with the geos. I found that if you do the legwork in advance, it helps deliver the bad news. turning the bad into a positive, if you will. Here's what happened, but here's what we learned. Next is the misinformed model, and this could easily fill the entire ethics hour by itself. However, I'll just touch on the key issues, or at least the key issues as I see them. Undoubtedly, every modeling workflow is unique, but they all have the same basic steps. You select a model, maybe a correlation, you input some assumptions, and then you match your model to actual data. And the models can be powerful tools. However, they also have a high potential for misuse. Some things I've seen done include treating a variable with considerable uncertainty as a known value. For example, if we don't have a good grasp on permeability, but we just plug in our best estimate, run the model, and never revisit the assumption. Another example is omitting data entirely. If we're putting together a type curve for an area and we exclude poor performers because they're outliers, then we're unfairly increasing the resulting type curve. Another example would be if we've history matched a model and then we apply it somewhere where it may not apply. For example, if we've history matched a well that's currently in its transient flow state, can we then use that to predict performance in a boundary-dominated flow state? Maybe. But the end result of a misinformed model is a misinformed development plan and potentially an incorrect net asset value. For example, we may use this model to determine optimal completion design and optimal well density for some unconventional play. But later we get more data and we learn the economics are much better when we have bigger completions and fewer wells. And the same can be applied for conventional plays. Development plans are highly dependent on if a reservoir is compartmentalized or how strong the water drive is. So how do we avoid these issues and get the most from our models? And my number one tip would be take the stance that the model is only a learning tool. It's not a black box prediction mechanism. Where you have highly uncertain inputs, run a sensitivity analysis and figure out which factors are most impacting the results. Let this drive future data gathering and research efforts. Also, you can't skimp on the due diligence steps. Good engineering takes time. Every model has inherent assumptions, and you need to know if they're still valid for your situation. And when you do get additional data points, revisit the model and refine the results. And finally, we get to my favorite ethical gray area, creative interpretations. And the issue really stems from the way the regulations were written in the first place. And I've heard from a credible source that the SEC intentionally kept certain things vague so that it will continue to apply as the industry evolves. Otherwise, they would have to frequently update the regulations. Furthermore, an exhaustive list which covers every possible scenario would be unreasonably large, so they have to generalize it to some extent. However, this vagueness and generalization forces us to interpret things, which can then end up being subjective sometimes. A literal rule might be stretched beyond its original intent. For example, I've seen many different approaches to how to select offset PUDs, some being on the aggressive side. In some instances, your specific situation might not be addressed at all, so you have to read between the lines to figure out what to do. One example is the classification used for PUDs that were debooked and then rebooked in a later year. Is that a revision or an extension? and there's no consensus in the industry as to which one it is. Or perhaps when creating a reliable technology polygon using SPWE monograph 3, what do you consider the proved area? Is it the entire polygon? Or is it just the area covered by the PUDs that you booked in the polygon? The shell example makes the risk of this situation clear. Whatever you decide to disclose as proved could eventually be scrutinized and become highly visible. And the SEC also benchmarks reserves metrics across different companies, so anomalies are likely to result in a comment letter. The first line of defense for these creative interpretations is a solid peer review. Discussing with your in-house colleagues will help refine your logic. Even better is to network with other professionals across the industry. For reserves, there are meetings organized twice a year with many different companies, and that's exactly what we discuss. How are we doing certain things? But I've also had luck just calling up counterparts and asking how they handle certain things to get a feel if we're different than what everybody else is doing. You may think your interpretation is the correct one, but it's a good check to see if everyone else disagrees. The last line of defense is the so-called red face test. Consider your decision and then assume it will be a major headline tomorrow. Would it cause you or the company embarrassment? Are you confident that you could defend the analysis? If not, go back and re-evaluate your decision. Finally, something I've seen greatly mitigate this is having a team responsible for compliance that does not report up through the same chain of command. For example, a corporate reserves team that reports up through a different executive. Asset teams may have a directive to push for reserves to lower their DD&A, which can pressure engineers to maybe slightly bend the rules and get as much reserves as they can. But having an independent team whose only goal is to maintain compliance creates this healthy push and pull where maximizing reserves on one side and following the requirements on the other side are equal priorities. So we've covered a lot of ground. We've gone over a couple of examples where engineering failures have resulted in physical damage and loss in life. We went through the shell example and saw what happens when a major misses the mark on reserves forecasts. And then I've also gone through some examples I've personally seen that maybe justify a closer look through the lens of ethics. But to wrap everything up, I'd like to leave you with a few tips I've picked up in my limited time in the industry. First, communicate levels of certainty with every prediction that you give. Get your management team to start thinking probabilistically. Next, understand the assumptions feeding into each of your models, whether it's something you've manually input or it's inherent in the model itself. Understand what the model means. Next, don't operate in a silo. Make use of your coworkers, join professional groups and ask questions there, and network with counterparts in similar roles whenever possible. And finally, my number one tip, always prioritize integrity. And I think if you do just that one rule, everything else follows. With that, I would like to thank you all for listening. We've made it to the end and we have completed it. I hope that there was at least some tidbits of value for you to take away, but If not, you've at least met your ethics requirement for the year. I would also like to again thank the fantastic team at PHDwin for inviting me to speak. It's been a great honor to get to speak to this group and to participate in PHDwin Week. I will be available later today for a live Q&A. I'm really looking forward to all of your good questions, and especially if you have any examples of maybe these ethical gray areas that you've observed that I didn't cover in my presentation. And if you can't make the live Q&A, you can always reach out directly. I'll make sure that my contact information is forwarded along. With that, thank you again and goodbye.